All right, party people. It is Mr. Gibbs, aka Captain Awesome. I'm back for another lesson. We are going into sequences in series. So here we go. I'm gonna try to go quickly to keep our video short. Obviously, you can pause as you need. So let's get down to it. Okay, so a sequence is simply a list of numbers in a specific order. Okay, so they're in a specific order. So like the most obvious one is the one when you count. You count 1, 2, 3, 4, 5, 6. That's a specific order. That is a sequence of numbers. Okay. The domain. So we're going to be basically talking about domain and ranges, except we're not going to call them domain and ranges anymore. The domain is now known as the position, and the range is now known as the term. Okay, so domain is the position, range is the term. Okay, so in our sequence down here, we can see 1, 2, 3, 4, 5. Well, what do you think comes next? Well, we have 6, 7, 10. Just kidding. It's 8. So 6, 7, 8, 9. Okay, and then for each position, we have a term. So 1 is 2, 2 is 4, 3 is 6, 4 is 8, 5 is 10. And then you can see the pattern down here. It's going to be 2, 4, 6, 8, 10, 12, 14, 16, and 18. Okay. Pretty straightforward on that. It's really just trying to get you to recognize that there's a pattern here, and that you have the domain is now the position, or n, the range is now the term, or f of n. Okay, and so we come down to our second one, and you can see we still have our same inputs or our domains or our positions. So we'll label that our domain or positions. Okay, and that's n. And our range or our term, which is f of n. And so we're going to see 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then that's our position, right? So that's our inputs, it's our domain. And our outputs are 1, 1, 2, 3, 3, 5, 4, 7. And so you're looking at the pattern here. 1, 3, 5, 7, 9, 11, 13, 15, and 17. Okay, so it just gives us, you're just again looking for the pattern. And there's sometimes you're going to have a pattern that you're not going to be able to just predict, right? Like if I say, okay, so if I'm asking you about position 1 million, like, are you really going to count to 1 million to get to your pattern? No, there's got to be a way to get there without actually having to count all those things. So let's jump into, I'm going to skip why our relationships are functions, and I'm going to jump down to the recursive rule. Okay, so the recursive rules, you have these word rules, and sometimes people get confused by them about rules. Like, is that a rule like I have to raise my hand before talking type of rule? No, it is a rule that's a formula. Okay, and for the recursive rule or formula, okay, we could call it a formula. Okay, and our rule down here is still a formula. Okay, our formulas are there's two different basic types. One, you have to know some more information than the other, and that's our recursive rule. And the recursive rule, we have to know, you must know the previous term. Okay, to get the next. Okay, you have to know the previous term to get the next term. The explicit rule, you just substitute in and it works it out on its own. You don't have to know the previous term. So you simply substitute in the position and simplify. Okay, so again, there's the recursive and the explicit. So down at the bottom of your paper, you have two categories here. This is going to be our recursive rule. These are our explicit rules. So let's just label them real quick so we know which ones we're talking about. This is the recursive, and this is our explicit. Okay, so these are our recursive, these are our explicits. So our recursive rule, you can see that it's giving us our formula here, and don't be confused by that f of n and f of n there and n minus 1. This is talking about our position, okay? F of n is just a position, okay? So, and I'm sorry, f of n is our term, n is our position. So f of 1, so f of position 1 is 5. That means if I substitute 1 into my formula, I'm going to come out with 5. So if we make a t-chart over here, and we have our n and f of n, well, if we substitute n as 1, our function, our f of n, is 5. So now I want to know what 2, 3, and 4 are, because it's asking us for our next 4 terms. So we're going to start substituting these things in. We already know what f of 1 is, so we don't need to substitute 1 in, but we do need to substitute 2 in. So we're going to start off by f of 2 equals, we're going to keep that 2, that's a part of the function, okay? It's just a part of the formula. And we're going to say f of, well, we've replaced n with 2, so we're going to plug 2, or substitute 2 in there. 2 is 2 times f of 2 minus 1. Okay. And so what is 2 minus 1? Well, 2 minus 1 is 1. And so we have 2 of f of 1. So we started off with substituting n into 2, or 2 into n, and 2 into n here. And now we're saying 2 times whatever f of 2 minus 1 is. Well, f of 2 minus 1 is f of 1. Well, we already know f of 1 because it says f of 1 is 5. So we can say 2 times 5, which is 10. So f of 2 is 10. Okay, and maybe some of you are already starting to see the pattern there. Awesome, but I'm going to go through another one, all right? Because I know that this part probably looks a little tricky, but I think once you start practicing it, you'll get used to it. So we're going to substitute in 3 for n now because we're looking at position 3, and we're going to substitute 3 in there. 3 minus 1. Okay. And we have equals 2 times f of, well, what is 3 minus 1? 3 minus 1 is 2, so we have f of 2. Well, do we know what f of 2 is? Yeah, we know what f of 2 is. F of 2 is 10, so we can say 2 times 10. So we figured out f of 2 right here, and that's what we're going to be multiplying by. So we had to know the previous one, right? Remember back to our recursive rule? You must know the previous term. Well, f of 2 in this case is the previous term because we're currently looking at 3, and the previous one before it is 2. So we have 2 times 10 is 20. So we should start seeing our pattern here, right? We're multiplying the previous one by 2, and that's all this is saying. 2 times whatever the previous one is our new one. So 2 times 5 is 10. 10 times 2 is 20. 20 times 2 is 40. So once you get a couple in there, you don't have to do anymore because you're starting to see that pattern. But for the first 2, when you're doing this on the test or when you're doing this on your homework today, I want to see 2 before you start predicting what the next one they're going to be. Because if you don't get 2 more, like you're just not going to make it. Okay, Now, if that wasn't confusing enough, let's throw another type of notation at you. You've got to be able to do both according to the homework, okay? So a sub n and a sub n minus 1 plus 20. Well, a sub n is now replacing f of n. And then a sub n minus 1 is replacing f of n minus 1. So it's saying the same things in just a different notation, okay? So I'm almost at 10 minutes. I'm really trying to keep this thing under 13 minutes. So I'm gonna go super quick, and if you need me to stop or slow down, just hit the pause button, all right? So our first number in the sequence here, okay, we've got to know what f or a sub 1 is, right? But I didn't put it on here, so you're gonna have to write it down. A sub 1 equals 10. Okay, so if we know a sub 1 equals 10, our very first term, remember I said you've got to know the first term? Well, here's a sub 1 equals 10. I didn't put the first term in here originally, so I'm giving it to you right now. So we can make our t-chart again. And we've got n, and it should be a sub n. So it's just a different notation. So I'm looking at 1 is 10. And so now I want to know 2, 3, and 4. Well, if I know 10 and I know my first one, I can actually start substituting in 2 here. So it's going to be a sub 2 equals a sub 2 minus 1 plus 20. Okay, well, a sub 2 equals, well, what is 2 minus 1? It's 1. So we know it's a sub 1. 2 minus 1 is 1, so a sub 1 plus 20. Well, do we know what a sub 1 is? Yeah, look up here. It's given to you right here. So a sub 1 equals 10, so we're going to substitute in 10 for a sub 1 plus 20, and that equals 30. So we're going to say 30. Okay, remember how I said I wanted you to get another one in there? Let's practice one more. So we're going to say a sub 3 equals a sub 3 minus 1 plus 20. So again, we're just replacing the n's with 3. So a sub 3 equals a sub 2 plus 20. Well, a sub 2, we got to just look back at our previous one. A sub 2 is 30. So we're going to say 30 plus 20, which equals 50. And so now I can predict that next one. I've got 10 plus 20 is 30, 30 plus 20 is 50, 50 plus 20 is 70. Okay, so that's the explicit rule. And you have to know the first term for the explicit rule, or at least the previous term. Okay, so, but in our cases, we're probably going to give you the first term. Okay, so you've got to know the first term. You'll notice that f of 1 or a sub 1 is missing on both of these, and that's because we're talking about the explicit formula. We don't have to know what the first term is for the explicit formula. You just have to substitute in. So our f of 1 now, we're going to replace n. You leave the f there. And we're going to replace n with 1. Okay, and I like using those parentheses so I know exactly where I'm putting 1. And we're going to square it. So we have f of 1 equals, well, 1 times 1, or 1 squared is 1, plus 2, which equals 3. Okay? And now we're going to go f of 2. And I'm going to stop doing the double so that I can just show you. We're going to go quickly here. Keep our video short. 2 squared plus 2 equals, well, 2 squared is 4. 4 plus 2 is 6. So we could start a t-chart here. I'm going to say n and f of n, our output. So our input is 1, our output's 3. Our input's 2, our output's 6. And so now we're going to go f of 3. And we've got 3n plus 2. And that equals, well, 3 squared. 3 times 3 is 9. 9 plus 2 is 11. And so we have 3n and 11 out. And we need to do one more. So f of 4 equals 4 squared plus 2. So 4 squared is 16. 16 plus 2 is 18. So we have 4 in 18 out. Okay. All right, and our last problem, again, it's still an explicit rule. The only difference is that we have our a sub n and n here as opposed to f of n. So a sub n and f of n are really similar to each other. It's just a different notation that we're getting used to. Okay, so we can substitute our numbers in. So we're going to look for the first 4 again. Make your T chart. And so we're going to go 1, 2, 3, 4. And so a sub 1 equals 20 times 1 plus 100, which is 20 times 1 is 20, 20 plus 100 is 120. So n equals 1 gives us 120. A sub 2 equals 20 times 2 plus 100. So 20 times 2 is 40. 40 plus 100 is 140. Okay. A sub 3 is 20 times 3 plus 100. So 20 times 3 is 60. 60 plus 100 is 160. Oh man, I'm way over on time. And our last one, a sub 4 equals 20 times 4 plus 100 equals, well, 20 times 4 is 80. 80 plus 100 is 180. Okay, and there's our pattern. And you can see it growing by 20 each time. So 20, 20, 20, 20. We're adding another 20. Okay, that's it. If you need to rewind the video, rewind it. Bye.